Solving systems of equations, part 3. So this is example 5, solving a non-linear system involving a circle. All right, so we do use a lot of previous knowledge for a lot of concepts in Algebra 2. This time, the equation of a circle you should be familiar with from geometry. X squared plus y squared equals r squared is the equation of a circle. So we have an equation of a circle, and we have y equals negative 3x plus 10. This is a linear equation. So we have an equation of a circle and a linear equation. This is solved by substitution. Since this is already solved for y on the second equation, we can take this and substitute that in place of y on the first equation. So let's go ahead and do that. We're going to have x squared plus y squared equals 10. So we're going to have this right here get substituted in place of y. So negative 3x plus 10. All right, bring down your x squared. Now we have a binomial squared. Again, this is something you have seen before. A binomial squared, you square the first term, you do 2 times the first and last term, and you square the last term. All right, so the first term squared, negative 3x is your first term. So to square that, I'm going to get 9x squared. All right, then I'm going to do x times y, and then multiply that by 2. So this is x, this is y. So that would be negative 3x times 10, negative 30x. And then I'll multiply that by 2. So that's going to be negative 60x. And then I'm going to have 10 squared. That's your last term squared. That equals 100. And I accidentally put 100 on the end because that's where my brain was. So, but that is equal to 10, which is what it was in the original equation. All right, now we can combine like terms. So we have x squared plus 9x squared. Since those are common terms, we can combine those and get 10x squared minus 60x, and then plus 100 equals 10. So let's subtract 10 from that, and we get plus 90 equals 0. All right, now factor out your greatest common factor. Our greatest common factor here would be a 10. We're left with x squared. 10 goes into 60 negative 6 times, and 10 goes into 99 times. All right, now we can try to factor this further. All right, so we're going to have x times x, what multiplies to give me 9, and adds to give me 6. So that's going to be 3 and 3, and that's going to be both negative. So that's 10 times x minus 3 squared equals 0. All right, so 10 drops off. When I say drops off, we set our factors equal to 0, and 10 cannot equal 0. So this one can't be a solution. So we're going to do x minus 3 squared equals 0. So if you take the square root of 0, it's still just 0. So we're going to have x minus 3 equals 0. There's no plus or minus there because 0 is 0. That's not positive or negative. And then we just add 3. So x equals 3. So that gives us a solution. And then we can plug it back in to find what the y value is. Y equals negative 3 times 3 plus 10. So that'd be negative 9 plus 10, or 1. So we're going to have 3, 1 as a solution. All right, what I would do is I would take, and you can solve this for y equals and graph it. You can graph this one as well. If you go to desmos.com, it will graph it very quickly and easily. Actually, why don't we do that? All right, so if I go here, I can type in my 2 equations. So I can do x squared plus y squared equals, what was it, 10? And then, so there's my circle. And you can see that that does have a radius here, square root of 10. Whatever the square root of 10 is, it's going to be approximation here. But it's x squared plus y squared equals r squared. And so that's why it's centered around the origin. Our other equation was y equals negative 3x plus 10. And you can see now that it does cross at this. This is 2, this is 4, so that would be 3 and up 1. So that is 3, 1 is a solution there to that system. So Desmos calculator, that's a great thing to graph. Easier than solving this for y to put it in your TI-84. All right, you can see here a common error if you substitute the 3 into your first equation, into the circle equation, you're going to get 2 apparent solutions. But when you plug it into the second equation, it doesn't work. And if you use the graph to verify that, you can see on the graph that there is only one true solution to this system. All right, example 6 says solving a quadratic equation by graphing. Solve each equation by graphing. So we have 3x squared plus 5x minus 1 equals 2x plus 1. So this is one of our major standards where it says to solve an equation f of x equals g of x, first write the functions to represent each side of the function. So we're going to have y equals the left side and y equals the right side. And that gives us our 2 equations. And then we graph it and find the intersection point just like we do for any other problem. So then it says step 2, graph the functions. And the x value of the intersection points is the solution. So again, we're looking for the x values. All right, so we're going to go, well, let's first write our equation down. So we're going to have y equals, the left side is 3x squared plus 5x minus 1. And the other side is going to be y equals 2x plus 1. So that gives us, it's still basically the same thing as a system of equations. It was just one big long equation that we have to separate into 2 parts. So we've got 3x squared plus 5x minus 1. And then we're going to have 2x plus 1. And I'm going to hit graph. And you can see that there are 2 solutions here. Let's see if we can determine these from the table of values. Okay, so it looks like the negative one is not an exact solution. The other one must not be as well, because that one would have been between 0 and 1. So we're going to have to do second trace and get an approximate answer here. So let's get the intersection. Okay, I always like to do the left side first. So let's do inner. You have to be left of this point. This is our first intersection point. So hit enter. And it says the intersection is about 0.46 and 1.9. All right, so let's write down x is about 0.46. Y is about 1.91. So that would be one intersection point, 0.46 and 1.91. All right, does look like there's a second intersection. So we're going to go back and do second trace, intersect, and this time we want to find the one on the left side. So I still have to be below the intersection point here. And then I'm going to go to the other side of the intersection point. And then I'm going to let my calculator get the answer there. So x is about 0.46 and y is about 1.91. So this one must have been, maybe I did that one wrong. Let me check real quick again. Second trace 5, inner, negative. So I forgot my negative 1 point. Okay. All right, so this one would be all right, negative 1.46. So that's my first point. Okay, and my second point was the same thing except, well, now I've done forgot again. Sorry about that. Let's do this one more time. Except now I'm going to the other side again. All right, so this one doesn't have a 1. It just says 0.46. Okay, so x is about 0.46 and y is about 1.91. Yep. All right, so the other point would be 0.46 and 1.91. So these would be the 2 points of intersection, and those are just approximate. You can see I rounded both of them to 2 decimal places. It does not say how many decimal places, but I would round it to at least 2 decimal places if it does not ask. All right, a couple study tips. All right, you can think of this as solving the system of equations, y equals f of x and y equals g of x, by graphing. So what it's saying is you can set this up, y equals each equation, the left side and then the right side, and it's the same thing as solve by graphing. It also says you can solve this by using the quadratic formula as well. So graphing is a little quicker and easier, unless you're forgetful and you have to keep doing it over like I did. But graphing is probably the quickest and easiest if you learn how to do it well. All right, the last thing to finish up this lesson is a self-assessment. The first one, solve by graphing, and then answer this question and come back to see how you did. All right, hopefully you took a minute to do this and you found that x equals 1.76 and the other intersection crosses at x equals 0.24. If you wrote the whole ordered pair down, that would be fine. Just remember when you solve, you're looking for your x values. All right, this one says explain why the x values, or the x-coordinates of the points where the graphs of the equations y equals f of x and y equals g of x intersect are the solutions of the equation f of x equals g of x. All right, so the mathematical definition, or the mathematical answer here, is when the graphs intersect at a point, then b equals f of a. Remember, this is saying b. This is your y. Y equals this and y equals that. So remember in the previous problem when we put y equal to the left side, y equal to the right side, that's basically what this is saying. B is your y in this case. So f of x equals g of x when x equals a. So that's why your x value would be your solution. All right, if you have any questions, please let me know.